Hello everyone, I hope everyone is okay. We are still continuing with trigonometry, né? Still continuing with trigonometry. On the last video, lesson number 28, we spoke about the quadrants. We spoke about the quadrants and we spoke about the 6 trig ratios, sine, tan, and cos, and then we have cosec, we have cot, then we have sec. Angles in the first quadrant are expressed as they are, theta. Second quadrant is 180 minus theta, then we have 180 plus theta, 360 minus theta. Guys, I'm just going over what you did in the previous video. I won't explain in full details, né? If you want more details about the basics of trigonometry, please go and listen to lesson number 28. Okay, and then we had things like 90 minus theta, 90 plus theta, minus 90, and then theta minus 90. And then we spoke about square identities. We spoke about square identities, né? The square identities we have sine squared theta plus cos squared theta, which is equal to 1. Then we had sine theta is equal to 1 minus sine squared x is equal to 1 minus cos squared x, right? And then we have cos squared x, which is equal to 1 minus sine squared x. And then we have other square identities, whereby tan squared x plus 1 is equal to sec squared theta, then 1 plus cot squared x theta is equal to cosec squared theta, all together. And then the other trig ratios, not trig ratios, rather other identities, né? We have reciprocal identities. The reciprocal identities, the most important ones are, we have cosec of an angle theta, that can be written as 1 over sine theta. Sec of an angle theta can be written as 1 over cos theta, and then cot of an angle theta can be written as 1 over tan theta, all together. And then we spoke about quotient identities. Okay, there are only 2 quotient identities. The first one, tan of theta is equal to sine theta over cos theta, and then cot of theta is the inverse, to be cos over sine theta, right? Okay, and then we spoke about the 3 steps of simplifying in trigonometry. Okay, they're not necessarily okay, but there are 3. The steps of simplifying: on the first step, you must reduce all your angles. And then step number 2, check if you can change two things into one thing. Then thirdly, we said we must change everything into one trig ratio, and if we cannot do that, just change into sine and cos. Just change into sine and cos, né? So these guys are the steps that are important for simplifying, né? Here I was just recapping on what we spoke about in lesson number 28, which is the most important video you must listen to. Okay. Okay, today I want us to talk about spatial angles. Okay. Do you guys know? Okay. There's this thing called SOHCAHTOA. SOHCAHTOA is the relationship of the right angle triangle. Are you together? If we have an angle of theta, SOHCAHTOA simply says that sine of theta will be equal to opposite all over hypotenuse. Are we together? Opposite all over hypotenuse. Which side is opposite to the angle of theta? We have a right angle triangle, right? This will be the opposite. We'll call our opposite y, and the side which is adjacent to theta, we'll call it x. This, the longest side of the triangle, is called the hypotenuse. Let's call it r. Are we together? We call it r. The hypotenuse is always opposite the 90 degrees angle. Are we together? So sine is equal to opposite over hypotenuse, and cos of theta is always adjacent all over hypotenuse. Are we together? And then for the tan of theta is always opposite over adjacent. Are we together? And then this thing, if we want to write it in terms of x, y, and r, sin theta will be just y over r, cos theta it will be x over r, and then tan theta will be just y over x. Are you together? Okay, I said we want to talk about spatial angles, right? The angles are spatial because we know the value of x, y, and r. I like to focus on only 3 spatial angles because they are the most important ones. They will always appear whenever you see them. I like to just focus on only 3 of them. I have 30 degrees, 45 degrees, and 60 degrees, right? Remember, I'm focusing on x, y, and r. Please note that, guys, the r for all of the spatial angles is always 2. Right, together. And then for x and y, you just start counting here. From y, just say 1, 2, and 3. Then you come back and say 1, 2, and 3. And then all you need to do is to just put the square roots for both x and y. The square roots of 3. I don't need to put the square roots for the values of 1 because the square root of 1 will be 1. Are you together? So for example, if ever I want to find the sine of 60 degrees, I will go to 60 degrees. By definition, sine is y over r. I'll go to 60 degrees and check y over r. my y is square root of 3, and my r is 2. Even when I punch my calculator, I'll get the same answer. All together. Sine of 45 degrees, go to 45, and then I'll check my y is always root 2, and my r will be 2. When I want to find tan 30 degrees, the tan of 30 degrees is simple. I'll go to 30 degrees and check y over x. Y over x is equal to 1 all over the square root of 3. But in mathematics, we don't like to, we must not leave an answer with a set in the denominator. We must always rationalize. If you multiply the top and bottom by the square root of 3, you will find out you'll have root 3 all over 3. The calculator will just bring you straight here. All together. Okay, guys. So just know that angle 30, 45, and 60 are the special angles, right? So if ever I have something like this, remember that I said a number in trigonometry is made up of an angle and then of a trig ratio and an angle which is between 0 and 90. So if I have something like this, 120 degrees, are you together? My duty is to first reduce this angle. Are we together? 120 degrees is an angle in the second quadrant, and for me to reduce angles in the second quadrant, I must always use 180 degrees minus 60, and then this thing will give me a 180 minus is in the second quadrant where sine is positive, so I'll simply have sine of 60 degrees, which will give me the square root of 3 over 2. Are you together? So the steps, guys, are the same. You reduce angles, check whether there are two things you can change into one, change everything into sine and cos, and then simplify. So let's say now you have something like this. You have sine of 225 degrees multiplied by the cos of 300 degrees multiplied by cos of 180 degrees all over the sine of 300, let's say 315 315 degrees multiplied by the tan of let's say 315 as well. The first thing we need to do, guys, is to just open three brackets. Open three at the top and two brackets at the bottom, because we have two terms. Building a structure is very important. Okay, I'll just say sine 225 is an angle in the third quadrant. Are you together? And in the third quadrant, we express angles as 180 plus. So I can simply say 180 degrees plus 45. I know that this will give me 225 degrees, right? And then I'll have cos of 360 degrees minus 60. I know that this will give me 300. And then 180 is in the second quadrant, so we can for us to find 180, we must simply say 180 degrees minus 180 degrees. So this one you just leave it like this, now, guys. Angles in the x-axis or the y-axis, for example 0, 180, 90 and 270. It will be easy for us to find the values of those things. Are we together? Okay. For cos of 180 will give us a -1. Are we together? you'll see it properly, guys, whenever you do the trig functions. Why is it -1? Are you together? Cos of 0 would be 1. Cos of 180 would be -1. And then sine of 90 will be 1. Sine of 270 will be a -1. Out together. I will explain these things further when we see them graphically. For now, just know that the cos of 180 there is -1, né? Okay. And then I have 315. I can 315 is an angle in the fourth quadrant. I can express this as 360 minus 45 degrees. Are you together? And then 315 is also in the fourth quadrant. I know that I can get 315 by saying 360 minus 45. Okay, then now let me reduce the angles then. 180 plus is an angle in the third quadrant, right? 180 plus is an angle in the third quadrant, and I know that in the third quadrant sine is negative. Excuse me, so I'll simply have a negative sine of 45 degrees. Are we together? And then 360 minus is an angle in the fourth quadrant, and in the fourth quadrant cos is positive, so I'll simply have the cos of 60 degrees. Are we together? And then 360 minus as well is in the fourth quadrant where sine is negative. I'll have a negative sine 45. And then 360 minus as well is in the fourth quadrant, so tan is negative there, so it's negative tan 60. Are you together? Please note that since these two are the same, this will cancel with this, so I'll be left with negative cos of 60 degrees all over the negative tan 60 degrees. Are you together? The negatives will cancel as well, so I'll be left with cos of 60. By definition, cos is x over r. I'll go to 60 degrees and check what is the value of x over r. X over r is 1 over 2. So I'll simply write 1 over 2 there. 1 over 2. And then for the tan of 60 is equal to, tan of 60 is the square root of 3 all over 1. So I can simply, that's 2 then, so it's the square root of 3 all over 1. I can simply write this thing as 1 over 2 all divided by the square root of 3 is equal to 1 over 2 multiplied by 1 over the square root of 3. 1 over 2 times root 3. Then I can rationalize my denominator, because whenever, guys, I'm doing this, I must do this without the use of any calculator. Then I'll have the square root of 3. I'll have the square root of 3 all over 2 times 3, which is the square root of 3 over 6. Are you together? If you punch your calculator from here, the calculator will just get you straight to the answer. Are you together? The calculator will just give you this part. And if you're going to rely on the calculator, you are losing the mathematical knowledge in between. Are you together? You can pause the video, guys, and try to do this one on your own. I'll say sine 45 degrees multiplied by cos of 135 degrees multiplied by let's say tan of what? Yeah, tan 315. Yo, I made a mistake there, guys. Excuse me, guys. Yo. Askisin. This thing here, I just realized that I made a mistake. 360 minus 45 will not give me 60. It will give me 45. Yo. Excuse me, I only have a 45 degrees there, guys. So this thing over here will be a negative tan 45. This over here will be 1. So the final answer, it will be 1. It will be just 1 over 2. Askisini, guys. Guys. This will be the final answer. I made a mistake. At least I realized before concluding the video. Okay. Now let's not use 315 because we've used it before. Let's use 300. Let's say at the bottom we have sine of 120 degrees multiplied by the cos of multiplied by the sine of 310 degrees all over the cos of 120 degrees plus sine 300 all over the cos of 330. You can pause the video, guys, and try these things and try this thing on your own. Just open, since at the top you have 3 brackets, you'll just open 3 brackets as well. 3 brackets at the top, at the bottom, plus sine 45 is already reduced, so you just leave it like that. And then we have cos 135. This thing is the same as cos of 180 degrees minus 45. All together. And then here I'll have tan of 360 minus 60 will give me 300. And then I'll have the sine of 180 minus 60 degrees. Let's not use 310 there. Let's rather use 315. Okay. Sine of 360 minus 45, and then we have the cos of 180 minus 60. And then there at the top I have the sine of 360 minus 60 all over the cos of 3 all over the cos of 360 minus 30 all together. Okay. I still have sine 45 there, but now I have cos of 180 minus. 180 minus is in the second quadrant. The second quadrant cos is negative, so I'll simply have a negative cos of 45 degrees. All together. Then 360 minus is in the fourth quadrant, and in the fourth quadrant tan is negative, so I'll simply write negative tan of 60 degrees. All together. And then now at the bottom I have sine of 180 minus 60. 180 minus is in the second quadrant where sine is positive, so I'll simply have sine 60, and then 360 minus is in the fourth quadrant, sine is negative, I'll have a negative sine 45. 180 minus is in the second quadrant, cos is negative, I'll have a negative cos of 60. Alright, together. And then there at the top, 360 minus is in the fourth quadrant, I'll have a negative sine of 60 degrees, and then I'll have a positive cos of 30 degrees here. And then all I need to do is to just substitute the values of x, y, and r. Sine 45 is equal to the square root of 2 over 2. Negative cos 45, the negative square root of 2 over 2. Negative tan 60, the negative square root of 3. And then here I will have square root of 3 all over 2. And then I'll have the negative square root of 2 over 2 multiplied by negative 1 over 2. Plus, I have a negative the square root of 3 over 2 all over the positive square root 3 over 2. All together. I did say, guys, that trigonometry is just a game of numbers. It's just a game of numbers, ne? This is the same as this, they will cancel one another all together. So at the top I will be left with the negative of square root of 3 multiplied by the square root of 2 all over 2. At the bottom I will have the square root of 3, but now it's all over 4 because I'll be left with 2 times 2 there. All together. But this thing is added to what? These two things, they will cancel one another and I'll be left with a negative sign. So all I'll be left with is just minus 1. All together, guys. Whenever I deal with fractions, I do not want to have a fraction within a fraction. So what I'll do, I'll just multiply the top and bottom by the LCD, which is 4. Okay, whenever I multiply the top number by 4, the numerator by 4, I will have negative 2 multiplied by root 3 and root 2 all over the square root of 3 minus 1. And then this will cancel with this one. I'll be left with negative 2 multiplied by root 2 minus 1. So this is how, guys, you simplify. Né? I hope this video, guys, makes sense. I hope what I did here was to just simplify things for you. If you have questions, guys, please do not hesitate to ask anytime. Thank you very much.